Hey guys, hope you're well. Here we have a grade 11 Maths Paper 2 November exam. If you want to download the paper, just check the description below. A small tuck shop. Alright, so tuck shop, I used to love the tuck shop when I was in primary school. Oh man, it was so good. Okay, records, displays a record of the daily sales in rands. Okay, for the last 2 months. Now, they want us to complete the table, and you're going to use the histogram to help you. So let me explain. You see how the 300 to 400 category is over here? And can you see that the number is a 4? If you look on the y-axis, it's a 4. So that is how they got that. Okay. So if we then go to the 400 to 500 category, which is over here, if you read it off, it's 11. And then you just carry on, right? So this would be 21, 22. And then 600 to 700 is there, which is 13. And then 700 to 800. This was difficult. If I had a ruler, it would be lekker kwaai, my bro. 7, and then 800 to 900. If someone wants to sponsor me a ruler, that would be wonderful. There we go. That would be 3. Now, if we go and then do the cumulative, well, this is 4 plus 11, so that's going to be 15. 15 plus 22 is 37. 37 plus 13 is 50. 50 plus 7 is 57. And 57 plus 3 is 60. And they said 60 days. So let's now understand what this table is all about. What it tells us is that out of the 60 days that they are busy, what they're doing is, let's say you are the owner of your tuck shop. You want to see how much money is coming into your tuck shop and all of that. And so what they did is they looked for 60 days, and they noticed that on 4 of the days, the amount of money they made was between 300 and 400 Rand. On 13 days, for example, they made between 600 and 700 Rand. And on 3 of the days, they made between 800 and 900 Rand. And then, so all of these numbers, they're just telling us, how many days they made that amount of money. So this question now says, draw a cumulative frequency curve. Use the answer sheet. Okay, let me go check the answer sheet and see if I can pop it over here for us. All right, so I don't think we need that histogram. If we do, I'll obviously bring it back. But they want us to draw a cumulative frequency. So it's very easy. You always start with this number over here. So where's the daily sales? Okay, so we've already got that over there. So we can just put a little dot right down at the bottom. Then what we do is we only use these numbers now and these numbers. So the first one is going to be 400, and then it's going to go with 4. So that's going to be 400, and then 1, 2, 3, 4 there. Okay, and then you get the idea. Right now, it's going to go 500, which will go with 15. So 11, 12, 13, 14, 15. Yo. Sorry, this is quite small for me as well. My eyes are like shaking while trying to do this. 400 with 4. Where did that one disappear to? Yay! And then sound like a drunk father coming home from the shebeen. Sorry, just letting you into my childhood a little bit there. Kevin! I'm joking. Why are the numbers disappearing? 500 with 15, 11, 12, 13, 14, 15. Oh, I know why. Okay, 600 and then goes with 37. 700 with 50. And then 800 goes with 57. And then lastly, 900 goes with 60. So there. Okay. Now, you've done your ogive correctly when you're getting this kind of scenario where I'll try to draw it nicely, but I'm just going to do a rough curve for now. Oh, it's pretty decent first try. But if you got a graph that went up and then down, then you've done something wrong. Then you're probably using these numbers here. Okay, so I think I'm actually happy with that. I'm just going to leave it like that. Obviously, okay, I can't really use the excuse of a ruler because you wouldn't draw that with a ruler. But I could spend time and redraw it. Try to be as accurate as you can in your exam, but you get the idea. That's what the basic shape looked like. So it says draw a cumulative frequency, blah, 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 blah. Yes, we've done it. Okay, good. And I checked on the memo, they actually gave a mark for this point. So always remember, let me go through it again. This is always the first point, okay? 300. That's always like your starting point on the x-axis there, sorry. And then what you do is you go use these values and these numbers. You never use, on an OGIVE, you never use the middle numbers. Okay, now it says, use the graph that you drew in question 1.2 and determine the estimated median. So we know that median is n plus 1 over 2. N is always on the y-axis of this graph, okay? So on our y-axis, we knew we had 60 things, so we're going to say 60, and we also saw 60 over there, plus 1 over 2, that's going to give you 30,5. So then you go to 30,5, which is like there. Now, obviously, you would have a ruler, and you would go across nicely, and then you would use your ruler again, and you would go down, okay? And the value that you should get is around 580, okay? So my graph should have actually come down, because that's 5, 20, 40, 60. My graph should have come down there, or my line. But obviously you can see how crazy that looks. If I give it another go, yeah, it should have somehow hit there and gone down there. But obviously with the ruler and everything, you guys are going to get it much better than I will. And so 580. This one says, the tuck shop must make 475 Rand in sales per day just to break even. What do they mean by that? Let's talk about it. If you own a tuck shop, you might have someone working in your tuck shop and you need to pay them a daily rate. You need to pay your rent. You need to pay for your electricity, your lights. You even need to pay for all the food that is in your tuck shop. Maybe you have to make sandwiches. You need to pay for the bread, the butter, the bologna, you got to pay for all of that stuff that needs to go. So let's say, so they said that they need to make 475 Rand just to break even. So if they need to make 475 Rand just to be able to pay for everything in the tuck shop that day, the person helping them, the water, the electricity, the lights, the ingredients, if they make any less than 475, they're going home with a loss. And if they make anything more than 475, they're making a profit. But if they only make 475, then they're actually ending up making zero profit. Okay, so it says, on how many days did the tuck shop make a profit? Well, on these days here, they made between 300 and 400. It's actually not going to work in this table, I'll tell you why. But on 4 days, they made a loss. Now here we don't really know. Is it 450? Is it 420? Is it 475? So we can't use the table because this doesn't give us an exact amount. So what we rather do is we go to our graph, and we go to 475, which is going to be, that's 420, 440, 460, 480. So 475 would be somewhere like there. You would then use your ruler and you would nicely go up, and then you would go across. And when you go across, if you've done it accurately, you should come out here at exactly 10. Okay? So what does that mean? It means that on all of these days, all of the 10 days below, they made a loss. And then on the other 50 days, because remember there's 60 days in total, on the other 50 days, which is all of this above, which is all of this, that's all going to be profit. So the question said, on how many days did the tuck shop make a profit? 50 days. Not bad. 50 out of 60. Not too bad. Okay. Now, and you would have kind of gotten that from this as well. Like, for example, this is definitely profit. So even if you just add that up, that's 10, 23 plus 22 is 45. And then maybe like half of this, because we don't know how much of this was closer to 400 and which was closer to 500. But yeah, you get the idea. 50 seems about right. Okay, now on this one, it says, on the first day of the following month, the tuck shop made 725 Rand in sales. Very good. Does this day lie within the top 25% of sales from the previous 2 months? Okay, very easy to understand. Let me explain. So to work out the top 25% of sales, we need to understand that for example, on a box and whisker, we don't have to go draw a whole box and whisker now, but what we need to understand is that this is always your minimum, this is always your maximum, this is always your Q1, your lower quarter, this is your Q2, which is also your median, and then this is Q3. 25% of the values are here, then the next 25% is here, then the next 25% is here, and then the next 25% is here, so that you get a total of 100%. Let me just write this down. And then 25%. So let's go look at this data, and let's go find the top 25%. So to do that, you're just going to go find Q3. And to find Q3, it's always n plus 1 over 4, and then we multiply that by 3. That is how to find your upper quarter. And so you're going to say 3 multiplied by 60 plus 1 over 4, and that'll end up giving us 45.75. 45.75. So you would go up here to around 45, 46, somewhere around there, which would be 42, 44, sorry, 41, 42, 43, 44. Come on, Kev. 41, 42, 43, 44, 45, and then 46. So somewhere there, and then you would go down. Now obviously I haven't used a ruler, but you're going to get a value here. And if you've done this correctly, you should come out at 650 Rand. So that means that this value here is 650. So that means that to be in the top 25% of sales, it needs to be more than 650 Rand. So if the tuck shop made 725 Rand, then does that fall within the top 25%? Yes, because we just worked out that the starting point of going into the top 25% is 650. So if they made 725 in sales, they definitely did it. So we can just, in the exam, you would show the 650. So you would show that Q3 is 650. And then you would show that 725 is definitely bigger than 650. So therefore, yes. 5 data values are represented as follows. What are data values? It's just like values. Like let's say you wrote 5 maths tests and you got 60, 48, then you started watching Kevin Math Science and then you got 81%, 92%, and 96%. So these would be called data values. It's just values, okay? It's nothing specific. If the average or the mean is 15, calculate or show that k is 11. So how do you normally calculate the average? If I said find the average over here, you would add all of these numbers together and you would divide by how many numbers there are, which would be 1, 2, 3, 4, 5. So now we're going to do that with 1, 2, there's 5 data values, they told us. So we're going to go add all of those together. So 2k plus 1 plus k plus 2 plus k minus 3 plus 2k minus 2. We're then going to divide all of that by the number 5, and we know what the answer is. They told us that the average is already 15, so we can make that equal to 15. And now we can just work backwards. So you could imagine doing cross multiplication. So that means this 5 would end up going there, and the 1 would end up going to the left. But when you multiply by 1, it doesn't do anything. So the left is just going to stay exactly as it is. K minus 3 plus 2k minus 2. And that's going to be equal to 15 multiplied by 5, which is 75. Okay, now you just solve for k. So these 4, 5, 7k. And then if you look at all the numbers, it's going to be 1 plus 2, which is 3, minus 3, which is 0, minus 2. So then if we take the 2 over, we end up with 7k equals to 77. Divide both sides by 7, and k is 11. Okay, fantastic. Calculate the standard deviation to 1 decimal place. Look at that, 1 decimal place. Okay, so we need to get our calculators. But first, let's just go work out what these values are. So for example, 2k is going to be 2 times 11, which is 22. K plus 1 is going to be it's going to become 11 plus 1, which is 12. So you get what I'm doing, right? I'm just plugging the k values in here so I can see what the numbers actually are. So we eventually should get 22, 12, 13, 8, and 20. And now we can go put that on the calculator. Doesn't have to be in order when you're calculating mean or standard deviation, but to put it on your calculator, what you're going to do is you're going to put your calculator into stat mode. So press mode and then stat. Then you're going to choose 1 minus var or VAR. Okay. And then go enter all of your values. So 22. I wish all exams were like this, where they would just give us a few values. Sometimes they give us a klomp values. Hey, my bro. Sometimes they give us a klomp values, my bro. A klomp. Okay, and now we're gonna press Okay, sorry, I don't know. My traumas are coming back from sometimes if I go out to some clubs with my friends, and then you come back to your car and the car guard's like, "Jay bro, kyk gooi. Don't you want to spare me a 10 rand?" Okay. Right. So you entered all the values. Say, uncle. So press, sorry guys, I think something's definitely not lacquer with me, eh? But we keep pushing forward. Okay, so you press AC, then you press Shift, then you press the number 1 on your calculator, and now you're looking for VAR again, VAR, and now you're going to look for the funny symbol that goes like this. That means standard deviation, so press it, press equals, and you should get 5.2 if you round off to 1 decimal, 5.2. Okay, and then this last one says, if t units are now subtracted from each data value without doing a further calculation, explain how the mean and standard deviation. I'm actually seeing this question pop up quite a bit in exam papers. So let me explain how this works. I'm going to give you a quick little explanation on how these kind of questions work, and also what standard deviation actually means. So let's say we have two classes. We've got class 1 or class A and class B. Now let's say in class A, for a maths test, they got 62, 64, well no, let's say 65, 66, and then let's say there was someone who actually got 58. Okay, so if you had to go work out the average of these numbers now, you would get 63. Okay, and now when we talk about standard deviation, we're not going to go calculate it now, but what is standard deviation? Well, think about this carefully. Let me explain. The word deviate means to go off the path. So if here's a path that you and your friends are walking on, and if you decide to go that way, well, that means you are deviating. You are going far away or off the path. So when we are talking about deviation in maths, we are talking about how far from the average are the numbers? Are they very spread out, or are they very close to the average? Well, these numbers, they're pretty close to the 63. They're pretty close to the average. Okay, so this would be a very low standard deviation. But now let's look at class B. 32%, 58%, 72%, 80%, and let's say we got another guy over here who got 73 and then 80. If you had to go calculate this, the average would also be 63. But then if you look at the standard deviation, can you see that these numbers are not very close to the average? Some are very low, some are very high, and the numbers are just scattered and all over the place. So this would be called a high standard deviation. Okay, we could obviously go calculate it. Here you would maybe get, I don't know, 5. Maybe here you would get 13. I don't know, just giving you an example. Now you have a decent idea of what standard deviation does. Now let's have a look at this. If t units are subtracted from each data value, without doing a calculation, how would the average and the standard deviation be affected? Okay, so check this out, guys. You're going to love this. Let's say I subtract 4 from every single one of these. Then this would become 54. This would become 58, 60, 61, and 62. If you had to now go work out the average, so let's say here, new average, it would be exactly 4 lower, so it would now be 59. But look at the standard deviation. Can you see that the numbers, so now remember that the new average is 59 because it would be 4 less. can you see that the numbers are still very close to the average, right? So the standard deviation doesn't change, but the average did change. So that's the thing. When they change all of the data by the same amount, the standard deviation doesn't change, but the average does, or the mean does. So it says explain how the mean and the standard deviation would be affected in terms of t. So we will say that the mean will decrease by t. Okay? But the standard deviation will be unchanged. Because remember, standard deviation tells you how spread out are the numbers from the average. So we can see that now when the average is 59, we can see the numbers are still pretty close to the average, just like it was over here. That hasn't really changed. So your standard deviation doesn't change when you decrease all of the values or increase all of the values by a certain amount. In the diagram below, RPQ with PQM is, with P and Q that, and then they said full stop. Then they said M is the midpoint. Okay, so this is the midpoint of RQ. First question for 2 marks, determine the gradient of MQ. That's very easy. You should all get full marks there. Gradient of MQ, we're going to use the gradient formula. Always fill in your formula first. Then I'm going to use, this is my point 2 and this is my point 1. You don't have to do it that way. So you're going to end up filling in 0, take away minus 2, over minus 2, take away 4. And you're going to end up getting 2 over negative 6. If you typed it on the calculator, it will simplify to negative a third. This question over here says, determine the equation of line MP. Okay, so there's different ways you could do this. I think I'm going to stick to the most simple way, but just remember that these 2 lines over here are 90 degrees. So if you wanted to, you could easily switch this around and you would easily have the gradient of this line. Because remember that when 2 lines are perpendicular, when you multiply their gradients, you should get minus 1. But I'm not going to do it that way. I'm rather just going to realize, hey, they've given us the coordinates. We might as well just go work out the gradient all over again. Yes, it's probably a bit longer, but I think most of you watching this will find that a little bit more easier to understand. And so you're going to end up with 0 take away 6 over minus 2 take away 0, and that's going to end up giving you 3. And so now we have the gradient of this line, so we can say y equals to mx plus c. So y equals to 3x plus c. And then to find c, if you understand c very well and you understand what it does to a graph, you would be able to realize that it's going to be 6. But if you don't, I certainly didn't when I was in grade 11, I would just plug in a value on that line. So you could either plug in this point or that point. It doesn't matter. I'm going to plug this one. So this is my x, this is my y. So you're going to end up with that. And then if you solve for c, you should get 6. And so the equation is going to be y equals to 3x plus 6. Okay, this question says determine the coordinates of R. Different ways you could do this. No, actually not. There's only one way that I can really see, and that is to look on this line over here. And if I had to draw this more simply for you, you would have this. You would have R over here, you would have M over here, and you would have Q. And we know M is the midpoint. Okay, and we need to find R, which I'll call X and Y. So we're going to use the midpoint formula because we have the midpoint. Let's just put it more in the middle like that. So we know that, let's say for example, you did a maths test and you got 60 and then in your other one you got 72. How would you find your average or the middle of those 2 numbers? Well, you would add them together and divide by 2. So whenever you want to find the average of 2 numbers or the middle of 2 numbers, you just add them and divide by 2. So we know that the midpoint formula, you add the coordinates and then divide by 2, and then you do it for the y values as well. Now, we already know what the answer should be. We already have the midpoint. So the way we'll do this now is we'll take this one over here for the x values, and we'll say that the x value of point R plus the x value of point Q, when you divide that by 2, you should get the x value of point M, right? Think about carefully what I've just said. If you take the x value of this one plus the x value of this one, and you divide it by 2, just like the midpoint formula, the answer should be minus 2. And then when you do the y values, if you take the y value of R plus the y value of Q, then you should get the y value of M. And so now if we just go fill into our formula, we're going to fill in x over here, plus the x value of Q is 4, and then the answer for the x value at M is minus 2. So at this step, I would just cross multiply. So what you're going to end up getting is that this is going to end up multiplying up to that minus 2. So you're going to end up getting x plus 4 equals to minus 4. And then if you had to go solve for x, you should eventually end up with x equals to minus 8. So the x value of R is minus 8. Now if we do the y values, we use this now. So the y value of point R plus the y value of point Q over 2 should give us the y value of point M, which is 0. So we're going to cross multiply now, and you're going to eventually end up with minus 2 over here, and then 0 on the right, and so y will be 2. Okay, and so we've worked out the coordinates. This question here says, calculate the length of PQ in simplified surd form. Doesn't get easier, guys. To calculate the length, we're just going to use the distance formula. X2 minus x1 plus y2 minus y1. I'll just use this as 0.2, this is 0.1, doesn't really matter. And so we end up with the x value of 0.2 is 0, the x value of 0.1 is 4, the y value of 0.2 is 6, and the y value of 0.1 is minus 2. Then I would just go pop that straight into the calculator, and we should end up with 4 square root 5. They said leave it in surd form, don't use decimals, so 4 square root 5. This one, given that RPQT is a parallelogram. Okay, so the order there is very important. So it said start at R. So we start at R, then we go to P, then we go to Q, and then we would go to T. Okay, so to find T, I know it's going to be, you're going to go parallel to this line, so something like that. And then to go from R, you would go parallel to this line, so it would be something like that. Okay, I haven't done that nicely. Like that maybe, and like that. So it's going to be somewhere over here. Okay? Wow, I really haven't done that nicely. But you get the idea. It's going to be somewhere here. Now, to solve these questions, you just use inspection. Check this out, guys. If you just look at this from P to R, just look carefully what happens. What happens to the x values? Well, it went from 0 to minus 8. So what happened to the x value? It went down by 8. So the x value, so when you went from P to R, the x value went down by 8. And then look at the y value. The y value went from 6 to 2, so the y value went down by 4. So when you then do the exact same on the other side, when you go from Q to T, it's going to do the exact same. The x values are going to go down by 8, and the y values are going to go down by 4. So then what you do is you just look at Q's coordinates, and you do that. So you take away 8 from the x value, so it goes to minus 4. And then you take away 4 from the y value, so that'll just go to minus 6. And that's it. You don't need to give a reason for that. On the memo, they literally give you 2 marks just for that. Okay, and then last one says, explain why RPQT, that thing we've just drawn, explain why it's a rhombus. Now, some of you might be like, bro. They just said it's a parallelogram. Now they're saying it's a rhombus. Remember that all rhombuses are parallelograms. but not all parallelograms are rhombuses. The parallelogram, did you know that a square, a rectangle, a rhombus, they are all parallelograms as well. They all have parallelogram properties. So can a parallelogram be a rhombus? Yes. I haven't drawn this very nicely, but if I did, you would actually see that it's going to be more like something like there. Still haven't drawn it super nicely. That could actually go a little bit longer. Then like there. You would see that here we've got the diagonals, right? And these diagonals, they are intercepting at 90 degrees. That is a rhombus property. It's also a, I just want to double check something. It's also a square property, okay? But a rhombus can also be a rhombus can also be a square, but a square isn't always necessarily a rhombus. You don't need to know all of this in detail. This is more like grade 10 Euclidean geometry, but the shapes can overlap with their properties. So one of the properties of a rhombus is that the diagonals not bisect, but the diagonals intersect at 90 degrees. So why is it a rhombus? We can just say that the diagonals are perpendicular, and that'll get you your 2 marks. In the diagram below, line AC and BD intersect at B. AC is perpendicular. So all that I'm ever looking for here is just information that they haven't shown. Okay, this is important. The equation of AC is that. Okay, while alpha is the angle of inclination, and that is equal to that. Okay, all good. First question, determine the coordinates of C. So that's pretty straightforward because we have the equation of this line. They gave it to us as py minus x minus 5p. Don't worry about the p's and the x's and the y's. We know that to find a y-intercept, we make x 0. So that's immediately what we'll go and do. So you end up with py minus 5p equals to 0. Take the 5p over. And now to get y alone, I'm going to divide this p on the other side like that. And so the p's cancel, and so you end up with 5. So the coordinates at C must have an x value of 0 and a y value of 5. If the gradient of AC is a half, so this one's gradient is a half, show that P is 2. Okay, so check this out, guys. Py minus x minus 5p equals to 0. That's the equation that we have. If I gave you an equation like this, what is the gradient? Well, the gradient would be 3. So if you can take a straight line equation and you can rewrite it so that it looks like this, where the y is alone, then whatever's in front of the x is the gradient. So let's try get y alone here. So what we'll do is we'll take it over to the other, we'll take the x and the 5p over, so they both became positive. We will then divide everything by p. So we end up with y equals to x over p plus, now these p's are going to cancel, so you're going to end up with plus 5. Now, I'm not perfectly happy with how this looks. Instead, I'm going to write it as 1 over p and then x plus 5. So that means then that now we've got it written like a straight line. So the gradient is whatever's in front of the x. So the gradient is 1 over p. But they told us that the gradient is a half. So 1 over p must be the same as 1 over 2. So from this, we can immediately say that p is 2. But if you want to solve it, you can use cross multiplication. So that would go there, and that would go there. So you're going to end up with 2 equals to p. Okay, and that's what they wanted. Now this question, for 5 marks, calculate the coordinates of B. Now B is the place where this line and this line intersect. So we already have this line's equation. Let's quickly go write it out nicely. So we know that it's py minus x minus 5p, but we know that p is 2. So we can say 2y minus x minus 5 times 2. And so that'll be 2y minus x minus 10. So if we get y completely by itself, we end up with x plus 10. And then if we get the y alone, we divide everything by 2. Then we end up with y equals to a half x plus 5. Okay, so we have the equation of this line now. Y equals a half x plus 5. Now we need the equation of this line, but that's going to be easy because we know that these two lines are perpendicular. So we know that when two lines are perpendicular, you can multiply their gradients together, and the answer is -1. So if we take the gradient of AC, which we can see as a half, and they told us over here, then we can fill that in, and then we can just work out the gradient of this one by dividing the half on the other side. And if you type that in the calculator, you're going to get -2. So now we know the gradient of this line. So we can then say y equals to -2x plus c. Now to find the c value of this line, you need to plug in any point on that line, 0 and -10. So we can say y equals to -2x plus c, and then we can fill in -10 as the y. And if you eventually work out c, you're going to get -10. Some of you might have realized that that already is the y-intercept. So now we have the equation of this line. It's y equals to -2x minus 10. Now we have the equation of both of these lines. So how do we find out where they intersect? We make them equal. So we can say -2x minus 10 equals to a half x plus 5. Multiple ways you can do this. You can get a common denominator. But what I'm going to do is I'm just going to take this to the left and then this to the right. So you're going to end up with -2x minus a half x equals to 5 plus 10. And then here you're going to get minus 5 over 2x. And here you're going to get 15. So then you can think of it as 15 over 1. And then you can do cross multiplication. So you're eventually going to end up with that. And then you can divide both sides by -5, and you're going to end up with x equals to -6. So this x value here must be -6 where they are intersecting. Then to find the y value, you plug that x value into either this equation or this equation. It doesn't matter. I'm going to plug it into this equation. So we plug in an x value of -6. And we end up with 12 minus 10, which is 2. So we have the coordinates of B as -6, 2. This question says, determine the size of alpha. Now remember, as soon as you have a gradient, or remember, as soon as you have gradient, angle, inclination, and tan, we know that these three can all link together. So if you have the gradient, you can get the angle of inclination, and if you have the angle of inclination, you can get the gradient. So what do we know about this line? We know it's gradient. So we can then say tan or shift tan of a half, and that'll literally give you the angle. So you just say shift tan of a half, and that's going to give us 26.57 degrees. So 26.57 degrees. Next question says, hence or otherwise, prove that ABOD is a cyclic quad. ABOD. ABOD is a cyclic quad. Can you see it? I can see it already. It's probably going to be the bow tie. Check this bow tie here. There. Yay. Oh, why am I drawing like a hillbilly? Come on. There. there. There we go. Okay, you see the bow tie, guys? That's what immediately caught my eye. And so specifically, I'm looking at this angle, which they've just asked us to calculate, and this angle. If we could show that they're the same, it's a cyclic quad. Remember, there are 3 ways to show that something is a cyclic quad. If you're thinking, Kev, wait a minute, bud. There's no circle, so how can it be a cyclic quad? You don't need to have a circle for something to be a cyclic quad. If something is a cyclic quad, all that it means is that if you had to draw a circle, there would be a circle that would perfectly be able to touch all 4 sides. That's what it means if something's a cyclic quad. It means that if you had to draw a circle, it would be perfect and it would fit all 4 sides. Obviously, I've freehand drew that one, so it doesn't look amazing, but that is what a cyclic quad is. It's something that can fit perfectly inside a circle. Okay, so there are 3 ways to prove something is a cyclic quad. Either the exterior angle is equal to the opposite interior angle. That would look something like this. You've got the shape like that maybe, and you've got an angle on the outside. If that angle is the same as the opposite interior, so like if x and x, if they are the same, then it is a cyclic quad automatically. What that means is that if you had to draw a circle, it would perfectly touch all 4 sides. Now, obviously, I'm not doing it very nicely, but you get the idea. Number 2, if the opposite angles are supplementary, which means they add up to 180, then it's a cyclic quad. So what that would look like is if something like this, and if this was like 30, and this was 150, so if they add up to 180, it's a cyclic quad. So notice with 1 and 2, the shapes were very open, like that and that. See, it just looks normal. There's no lines going through the middle, for example. Then with the third one, it's when you have angles in the same segment. And that's the one where we talk about the bow tie. That's typically when they give you a shape like this. Like that. And then you can get this bow tie effect that you see. Right? And that's immediately what I saw, lines going through like that. So if you can prove that the angles in the same segment are equal, like those 2, for example, or those 2, then it's a cyclic quad. So I think that's the one because they said hence, which means it typically refers back to that previous one. And we've just worked out this angle. So I think it's going to be to try work out this over here. And that'll actually be pretty straightforward to do. Let me show you. So what we can do, remember our goal is, let's see if we can try prove this angle is the same as this angle. So we're going to go work out this angle. The way we can do it is we can work in this triangle here. Okay, let's do that a bit better. And we know that this angle here is 90, and we could easily go and work out any angles here because we know the gradient of this line. So we can get the angle of inclination, or you can work out this angle, whatever. You're definitely going to be able to get this angle from that. So I'm going to go Shift tan. Now I don't put the negative on my calculator. I just leave it as a positive. And that'll give us 63.43 degrees. But now because I didn't put the negative on the calculator, that's not going to be the inclination angle, which is normally on the right. It's actually going to be the one on the left. So that's going to be this angle. You can see that it's the smaller angle out of this one and this one. So this angle here is going to be 63.43. And then if I just use vertically opposite angles, we're going to get that this one is also 63.43. And then you can just use sum of angles in a triangle, and you would easily be able to get this angle. Now, it's a bit irritating when they don't give you a letter over here because you can't really give it a label. Like, how do you tell them what angle you're actually working out? So I then checked on the memo, and what they rather did is they worked in this whole triangle here, And from that, they were able to work out this angle. Because we already have this one, and we already know that that's 90. And what's nice about that triangle is it's got a letter here. So you can say angle ACO, for example, and they worked that out. Then what they did is they worked in this triangle, because now we have this as 90, and we have this angle, and then they were able to work out that. So it's a bit irritating. My method obviously gives you the exact, you're going to get the same answers, but it's just difficult now to tell them what angle we're working out. But anyways, if you eventually go and work out this angle beta, you will also get 26,57. And so then we can say, therefore, theta is the same as beta. So therefore, ABOD is cyclic quadrilateral. Now we're going to say converse, and then angles in the same segment. Angles in same segment. And then this last question, determine the coordinates of the center of the circle which passes through D, B, and C. Okay, so there is a circle that is going to go through D, B, and C. Okay, now I'll show you something really interesting. It's going to do something like that. Now immediately, I know that this is the diameter. How do I know that that is the diameter? Because look at this. Look at that angle there. So we know that if you are in a circle, and if you have a diameter, then when a diameter makes an angle on the circumference, it's always 90 degrees. Angles in a semicircle, right? So here we can see there's a 90, which means that this line here has to be a diameter. So then, because I know that this line is a diameter, well then to find the center of the circle, I just find the midpoint of C and D. Easy as that. So C's coordinates are 0, 5, and D's coordinates are 0, -10. Okay, but let's also just tell them that we understand that CD is a diameter. So let's just say CD is diameter as it subtends angle CBD, which is 90 degrees. Okay, so then we can go, you can either use the midpoint formula over here, or you can just look at this carefully. The x values are not going to change. The midpoint is going to be somewhere on this y-axis. So the x value will be 0 for the center. And then what is the middle of 5 and -10? Well, that would actually take you to -2.5 or -5/2. If you cannot see that, then do the midpoint formula. So you can go find the midpoint of CD, and that's going to be using x1 plus x2/2 and y1 plus y2/2. And so we're going to use it for these 2 points here. So it's 0 plus 0/2 and 5 plus -10/2. And that will give you 0 and -5/2. If the following and cos is that, determine with the aid of a diagram. Okay, so this is a trigonometry triangle question. The goal is to figure out where to draw the triangle. From these two pieces of information, we will be able to draw a triangle. Let me explain. So we know that that's the first piece of information, and then we know that this is the second piece of information. So from the first piece of information, get this by itself. Just get that by itself, and you get 2/3. So what this is telling you is that the sin is a positive number. This is a positive number. So on this diagram, where can sin be positive? Well, sin can be positive here and here. Okay? Now we take this piece of information, and what that tells us is that cos is smaller than 0. What that means is that cos is negative, because if something is smaller than 0, it's negative. So on this diagram, where is cos negative? Well, I know that it's positive here and here, so it must be negative here and here. then it's easy to figure out that this is going to be the quadrant because it satisfies condition 1 and condition 2. So we will then draw our triangle. How do we draw it? Like this? Yay, what you doing? Like this, guys, from the origin. And then do you go to the right? Go down. There we go. So that is how you draw your triangles. Okay, let's draw it a bit bigger. Okay, now it's easy to go take this piece of information and remember that sin is opposite over hypotenuse. Some learners prefer y over r. So there's the opposite. So we're going to put a 2 because this is the angle that we're talking about, this angle in the corner. And this is the hypotenuse. And then when labeling the angle, just always go like this and then put the angle on the outside. Even though when you do the questions, I want you to pretend that we're using this angle on the inside. Just the way you label it, you're going to do it like that. Okay, now to find this side, you're going to use Pythagoras. So you're going to say 3 squared equals 2 squared plus, you can call this x. And you're going to end up with 9 take away 4, which is 5. And then if you take the square root, you get square root 5. So we'll put square root 5 there. But then I'm going to put a negative because I know that this is on the negative x-axis. Okay, now we can go work out all of these things. So when you see 3 cos squared b, just say 3 and then cos b and then square that minus 1. So if we can go work out cos b, then we just fill it in here. So what is cos b? So you're going to pretend that your angle's here and you're just going to get cos. Now cos is x over r or adjacent over hypotenuse. So it's going to be minus square root 5 for the adjacent over the hypotenuse, which is 3. And so if we have to go now and I would just type this part on my calculator, or this part here, sorry, and that would give you 5 over 9. I would then type all of that on the calculator, and you're going to get 2 over 3 as the answer. 2 over 3. Okay, now with this next one, remember that this does not look like anything on the cast diagram. On the cast diagram, we get 180 minus beta, 180 plus, and 360 minus. This does not look like that. And no, you can't take a negative out as a common factor when it's an angle. So what has Kevin told you guys to do? Well, I've always said if it doesn't look like anything on the cast diagram, you're either going to have to add or subtract 360. I'm going to add 360 because if I subtract, then this will go all the way to minus 540. Okay, so by doing it like this now, we're going to end up with minus b plus 180. And when you plus, the order doesn't matter. So it's actually the same as 180 minus b. And I know that that is on my cast diagram. But I know that tan is negative here. So I'm going to say negative tan b. And so I'm going to say negative. And then I'm going to go calculate tan b from my diagram. I know that tan is opposite over adjacent. Or if you prefer the XYR method, it's y over x. So it's going to be 2 over minus square root 5. And the two negatives will cancel. And so you end up with 2 over square root 5. If you typed this in on your calculator, it's going to give you something different to this. It would have given you, let me just check, 2 square root 5 over 5. It's the same thing, and they probably will give you your marks. They typically, I don't see them penalizing this too often. As long as they can see all your steps, you usually will get your marks. Given that t cos 15 is equal to 4, determine the following without using a calculator. Okay, so this is a quadrant question. Now, normally they would give you a question like they'll say sin theta is equal to 3 over 5 and cos theta is smaller than 0. And then from that, you would normally have to try figure out which quadrant you're in because they don't give you the angle. But in this question, they've given us the angle 15 degrees. 15 degrees is in this quadrant, because remember it starts here at 0 and goes up to 90. So we are in quadrant 1. Draw a triangle. Then what you do is you take this information and you get the cos 15 alone. So you divide by t. So now they're telling you that the cos of the angle 15 is 4 over t. Now we know that cos is x over r, or adjacent over hypotenuse. So that means that this is the adjacent and this is the hypotenuse. And then we use Pythagoras to find this side. So we could say, let's label that y for now. So we can say t squared is equal to 4 squared plus y squared. Then you can take the, you can get the y squared alone by saying that. And then square root, you can just say t squared minus 16. And so we can then go put that over there, t squared minus 16. And now we can answer the question. So the first one says, what is the sin of 15? So we know that sin is opposite over hypotenuse, or you can think of it as y over r if you want. So 15 is here, so the opposite is going to be square root t squared minus 16. And then the hypotenuse is t. And that's the answer. Some learners might be thinking, Kevin, isn't this just t minus 4? No. You cannot take the square roots if there's more than one term on the inside. Okay. Now the next one is sin 75. Now 75 is always going to be, it's this angle over here. Because if you just do sum of angles in a triangle, you would get this as 75. So then if you go work out the sin of 75 using opposite over hypotenuse, then the opposite of 75 is going to be 4, and the hypotenuse is still going to be t. So you're going to say 4 over t. Okay? And then this question says 1 minus tan squared 15. So the way you can think about that one is just 1 minus, then tan 15, and whatever tan 15 is, just square it. Super easy actually, because tan 15 we can just get on the diagram. So we know that tan 15, well, we know that tan is opposite over adjacent, or y over x, depending on what you prefer. And so if we then go opposite, it's going to be t squared minus 16, and adjacent is going to be 4. And then you just square that. And so you're just going to end up with t squared minus 16 at the top. And then if you square the bottom number, it just becomes 16. And you cannot cancel these because there's more than one term at the top. So yeah. Then I would get to simplify this all a little bit better, I would get a common denominator, which is 16. So I would write that as 16 over 16 minus that over there. And then because my denominators are the same, I can't cancel them because it's not an equation. But what I can do is I can leave it all over 16. And then I can say 16 minus. Now be careful, this minus is going to jump here and here. So it's going to end up becoming minus t squared plus 16. If you got minus, it's because you need to be careful with this negative that jumps to both. And at the top, you're going to end up with 32 minus t squared over 16. Simplify the following to a single trig function without using a calculator. Okay, so this one here is a co-function. We have got 4 co-functions. We've got that, and then we've got the ones where you plus. So they all become the opposite. So this becomes sin theta, this becomes cos theta, this becomes cos theta, this one becomes negative sin theta. So we've been given this one. So we're just going to replace this with sin alpha. Just like that. Then what I've told you guys is whenever you have something that doesn't look like something on the cast diagram, which is 180 minus, 180 plus, and 360 minus, then you need to either add 360 or minus 360. So this is already very negative, so I'm going to add 360. So it's going to become minus alpha plus, minus 540 plus 360. So that's going to become minus 180. So that's going to become minus 180. Okay, but now I'm still not happy with that because that still isn't something over here. So what I'm going to do is I'm going to add 360 again. You're allowed to add or subtract 360 as many times as you need to, because this is going to give me plus 180. There we go. Now, all of a sudden, because this is a plus, the order doesn't matter. So we can actually write it as 180 minus alpha like that. And now we have something over there. Fantastic. Then the next one, this is just a number now. So we're going to rewrite that as, now which quadrant is 225? That would be quadrant 3. So we write it as 180 plus. Now 180 plus what? 45. Because I know that that gives me 225. Okay, then I have a plus, sin alpha. I'm not going to do anything with that. This is lovely because it's already on my diagram. I know though that sin is negative there, so I'm going to put negative sin alpha. Okay, now we go into the next step and we just go simplify a little bit more. So this just becomes sin alpha because it's in the quadrant where sin is positive. 180 plus is already on the diagram, so that's perfect. So I'm just going to make it tan 45. And I can keep it positive because tan is positive in this quadrant. And then these parts here are all going to become a negative because you've got a negative and a positive. And so this whole part here becomes negative. And then sin times sin is going to be sin squared alpha. And then these two are also going to be sin squared alpha. And no, you cannot cancel these out because it's one term at the top, two terms at the bottom. So what we can go do next is tan 45 is just 1. Okay, you could even use your calculator for that. They don't care about that part. And then you've got this. Okay, now this part here at the bottom should be looking familiar to you. We know that sin squared plus cos squared is 1. So if I had to get this by itself, it would give me 1 minus sin squared. And that is exactly what we have over there. So what that means then is we can replace this with this. And now whenever we have a sin, normally when we have sin over cos, it's tan. Now we have sin squared over cos squared. So the answer is going to become tan squared alpha. Given that 1 minus cos theta is equal to that, show that the equation can be written as this. Okay. So I see that there's a whole bunch of cos. There's no sin. So what I'm going to do is I'm going to, in brackets, now I know that there's a sin squared theta. But I know that sin squared theta plus cos squared theta is 1. So then what I can do is I can replace sin squared theta with 1 minus cos squared theta. And so I end up with that over there. Then I'm going to take everything to the left so that that's positive, that's negative, and then this 2 is going to come over, so we're going to end up getting plus 1 minus 2. And if we then simplify, we get that. And then if you just factorize, you will end up, you can think of it as 2x squared take away x take away 1. You would eventually get 2 cos theta plus 1 cos theta minus 1. And so we've done that question. We don't have to go solve any further. Okay, and then the next one, hence determine the general solution. Okay, so now they just want us to solve. So 5.4.2, we can just write our equations down. Okay, so we can just say that the first one is equal to 0, or that. And then here you're going to take the 1 over, and you're going to end up getting cos theta equals to negative a half. And then for this one, you're just going to get cos theta equals 1. Okay, so now we're going to go do general solution. And so for this cos theta equals negative a half, we first need to get our reference angle. So the way we'll do that is we'll say shift sin of a half. I don't put the negative on the calculator. And we get 60 degrees. Then, because they're saying cos is negative, where is cos negative on the cast diagram? Quadrant 2 and quadrant 3. So those are the two quadrants we're going to work in. Okay, so in quadrant 2, we're going to say theta equals, now quadrant 2, we always say 180 minus. In quadrant 3, we always say 180 plus. Now, you're going to say your reference angle and your reference angle. And then we always say K360, K element Z. Plus K360, K element Z. And now we're just going to solve. So we're going to get 120 over here. And then here we're going to get 240. Okay, and then for this one, if you've watched my videos, you know that whenever it's a 0, 1, or a -1, I use the graph method. I find it very easy. I know a basic cos graph goes like this. So where is a cos graph equal to a y value of 1? It's here at the beginning at 0 degrees. So I say 0 degrees. And then how often does it repeat? Well, it only repeats again over there. So it's every 360. So that will be the K part, every 360. So what this tells me is that theta is 0, and then it repeats every 360 degrees. And so there are our three solutions, this one, and this one. In the diagram below, they've given us the graph of tan x minus 1 and then g of x equals to negative half cos 2x. So you obviously know that the tan graph is this one here, and the asymptotes are part of a tan graph. And then the cos graph is this. So the first question says, write down the period of G. Now, in a like a sin and cos graph, the basic formula goes like this. And the only letter that affects the period is this one here. Okay, if it was a cos graph, it's exactly the same. So K is the only letter that affects the period. So the period is always going to be equal to 360 if it's a sin or cos graph, because a normal period on a sin or cos is 360. And then you divide this by K. So the period is going to be 360 divided by our K value, which is 2. And so that's going to be 180 degrees. Then this question says, determine the range of G. So range is Y values. So, okay, they haven't given us, oh no, they have given us the values. So it's going to be a half. Can you see negative a half? And then it's going to go up to a half. So we'll just say that Y is an element going from negative a half up to a half. If you want to use set builder, you could say Y is bigger than or equal to minus a half, smaller than or equal to a half. Now it says, use the graphs to determine graphically the values of where is, okay, so what that means there is, where is graph F above x-axis? But they also said and equal to. So above the x-axis or touching the x-axis. Okay, so if here's the x-axis, whoops, then where is the graph above? Well, it's only here. So it's when the x value of 45 up to this asymptote, which is at 90. So you're going to say x is an element. You can also use set builder. I'll show you now. You can include the 45, but you never include the asymptote. Okay? They included, so we can include the 45. And then if you want to use set builder, you could rather say x is bigger than or equal to 45 and smaller than 90. On the memo, they included 90, but I can promise you that that is a mistake. Trust me, I record exam papers a lot. I see at least, I wouldn't say well, lately, the last like 4 exam papers I've recorded, I've seen a mistake in pretty much every single one. So it does happen. Okay, and in a question like this, I always use the table method. If you've watched some of my videos on this, you would know what I'm talking about, where I take the 2 parts, and I know that they want us to multiply these 2 parts together, and the answer must be bigger than 0. So the answer must be positive. So the only way that I can get 2 positives, the only way I can get a positive answer, because that's what bigger than 0 means, is if this one's positive and this one's positive, or if this one's negative and this one's negative. So I'll call this scenario 1 and I'll call this scenario 2. So let's go investigate scenario 1 now. Okay? So, in scenario 1, f must be positive. That means above the x-axis. So that is only over there. Okay? So, in that little area, so pretty much just in this area here, from this x value to this x value, the graph of g has to be positive. In that little area there, from there to there, graph of g is not positive. The graph of g is here, which is under the x-axis, so it's negative. So this part is a no solution. Okay? Next, we're now going to go look at scenario number 2. In scenario 2, graph f is negative. So the tan graph is negative, so that's there and there. Now, in those areas, so from, and I don't know why they've stopped here, but remember, this goes all the way up to the asymptote. So from from minus 90 up to 45, that graph is negative. So from there to there. And then for this one, it starts at the 180 and goes up to the asymptote as well. So from there to there. So those are the areas we're now going to look, okay? In those areas, do we see graph G being negative? Well, yes, here, okay? And not here. Don't say this part here, because you can see the yellow, or not here at least, the yellow, we didn't choose the yellow over here. The other part where graph G is going to be negative is here. There. So those are the areas where both graphs are negative. So it's going to be from minus 90, but we can't include minus 90 because it's an asymptote, up to minus 45, and we won't include it because they haven't included it over here. And then, or it's going to be from 90 again up to 135. And you could say x is an element. Now, if you prefer, and then some teachers will say or like that. If you prefer set builder, you could say x is bigger than minus 90, but smaller than minus 45. Or, so this one we normally say like that, x is bigger than 90 and smaller than 135. Okay, now with this question, we usually have to somehow be able to do something with these equations, because think about it. How can we use the graphs to solve this when these graphs aren't even those? So that's what they always like to do. They give us this, and then we need to manipulate it to somehow give us something like this. So let's see if we can begin. So, okay. So the first thing is, here we have a tan, but here we have a 2. And here we have a cos, but here we had a half cos. So I can immediately see if I divide everything by 2, that would be a good start, because then I get tan and then I get a half cos 2x, and then here we're going to get 1. Now, what we could do is, okay, I know that we had tan x minus 1, so I'm going to bring this over, so we get tan x minus 1, and then I'm going to take this to the other side, and now, guys, have a look here. Tan x minus 1 is that one, and then negative half cos 2x is that one over there. So now they're actually just asking us the following: where is the tan graph equal to the cos graph? And that we can literally see on the diagram. Where do they intersect? There, and oh, is that the only place? So we're literally just gonna say 45 degrees. So you'll get your 3 marks by showing this whole derivation of how we got there. Okay, now this question over here says, if h, okay, so h is a totally new equation, describe the vertical translation of h from f. Okay, interesting. So we know that f is currently tan x minus 1. Now, h of x is equal to sin x plus cos x over cos x. Okay, now they want us to describe the vertical translation of h from f. So how do you go, okay, well, how did they translate? So what we're going to need to definitely do first is we're going to have to try arrange this equation to try make it look, well, even, oh, it's actually very easy. We can, you can either change this one or change this one. I'm going to change this one by writing it as sin x over cos x plus cos x over cos x, right? I just broke it up like that. Now, sin over cos gives us tan, and cos over cos gives us 1. So h of x is now like that, and f of x is like that. So how do you go from this to this? So pretty much, how do you go from minus 1 to plus 1? Well, all that they would have done is they would have taken the graph of f and moved it up by 2 units. So translated 2 units up. Because if you plus 2 units on here, then you would end up getting tan x plus 1, and that's exactly what this one is. Okay, thought it was going to be a lot more tricky. This one, determine the maximum value of p if it's 4 times g. Well, if you look at the graph of g, it's the cos graph. What is its maximum value at the moment? Well, its maximum value is a half. So if you take 4 times that, well, that's just going to give you 2. So the maximum value of that must be 2. In the figure below, triangle ABC is drawn, and AB is perpendicular to BC. We can see that. Angle ACB is P, and then CB is 3 times the length of AB. Okay, so I'm gonna let AB equal x, then CB will be 3x, just so we can have a visual on our diagram. P over 2, that is the angle over here. Okay, and then they gave us this angle, and they gave us that length. Okay, so first question for 2 marks. Determine the value of P correct to 3 decimal places. Okay, very simple. In this 90-degree triangle that we have at the top, we currently have x and 3x and an angle P and a 90 degrees. So we can use our grade 10 formulas, sin, cos, tan. Let's see what we have. Opposite that angle, we have an opposite and we have an adjacent. So that's tan. So check this out. We can go tan of angle P is equal to x over 3x. And so the x's cancel, and so you end up with tan P as a third. So then to get P by itself, you're just going to say tan minus 1 of a third. So you're going to say shift tan of a third. And then they want 3 decimal places. That's going to be 18,4, 3, and then it'll round up to 5. So 18,435. Now in this next question, they say if P is 18.4, okay, so let's rather use it like that, determine the length of CD. Okay, so we now have that is 18,4. This is P over 2. So half of 18,4 is 9,2 degrees. Okay, and they want this length over here. So that's easy. That's a Sine rule question because here we've got opposites, and then here we can also use opposites. So you know the formula A over sin A equals B over sin B. Well, we're going to use it as 121 over sin 135. See, 121 over sin of 135 equals to CD over the sin of its angle, which is 9.2. Now, to get CD alone, you're going to have to multiply the sin 9.2 over. So you're going to end up with 121 sin 9.2 over sin 135 equals CD. And if we have to go solve for CD, we should get 27.36 27.36 meters. The diagram below represents an open tank. Okay, so there's no lid, with a square base and a height of h. The tank has a volume of 490. Okay, and then they give us the volume. Okay, and then they say determine the height in terms of x. Okay, so what we can do is we can go get the volume. So we know that volume is equal to the area of the base. So the base is always this part at the bottom. So the area of that is just going to be literally, it's a square. So it's just going to be x times x, which is going to become x squared. And then volume is area of base, which we've done, and then times height, which is h. Okay, so that's the formula for the volume for the shape. So we're going to fill in 490. We're then going to get this as x squared, and this is h. So it says find the height in terms of x. Okay, so get this by itself. So the way that you'd get that by itself is you divide by x squared, and there's the answer. So we have 490 over x squared. Then this one here says show that A, which is the external surface area of the tank, will be given by that formula. Okay, so don't even look at that. Just go find the surface area. So you got to understand that there's a surface area at the bottom. There's a surface area on the side, this side. So it's let's do it step by step. So we've got this piece at the bottom. Okay, then you're going to have this piece on the side. You're going to have this piece over here, this one over here, and this one here. I can't remember if I showed that one, but we won't have the top. Why? Because there is an open tank, so it doesn't have a lid. So to work out the total surface area, we're going to have the piece that's at the bottom, which is going to be x times x, which is x squared, plus. Okay, so we'll highlight whatever we've done so far. Now for the next one, let's do this. Let's do a different color. We're now going to do this. But can you agree with me that there will be 4 of those? Because we're going to do the front, back, left, and right. So there's going to be 4 of those. And each one is going to be length times height, which is going to be x times h. So we're going to end up getting x squared plus 4xh as your surface area. But notice that there's no h's over here. So what they've obviously done is they've replaced this h with the expression we found earlier. So we're then going to say a equals to x squared plus 4x, and then we're going to replace that h with 490 over x squared. And so now it's just a matter of simplifying a little bit. So 4 times 490 is going to give you 1960. Okay. And then we've got an x at the top and an x squared at the bottom. So it's almost like this. So obviously we're going to cancel out. So you're still going to have 1x left at the bottom. And so that is the expression that they wanted. So this is now the expression for area. Now they say, given that the tank is 10 centimeters high, okay, so given that h is 10, calculate the external surface area of the tank. Okay, so we know that the external surface area of the tank is given by this formula here. They've just told us that the height is 10. So we can fill 10 in over here now. So we can say 490 over x squared is equal to the height, which is now 10. We can then use cross multiplication, and you would eventually end up with that. Divide both sides by 10, you would end up with 49, because 490 divided by 10. And then taking the square root, you're going to get plus or minus 7. But you can't have a negative number for x because x is a length. So we're just going to say x equals to 7. So now we know what x is. We can then plug x into this formula. And so you're going to get 7 squared plus 1960 over 7. And this will eventually give us 329. And it's going to be centimeters squared because it's area. Here we have a proof. Now, you should all get full marks for proofs. Sorry if I sound like that teacher right now, but it's true, guys. With proofs, you know, I know that they're not the most nice or the most exciting things, but you know they're coming, right? And it's good. You should be, okay, I don't know what I just meant when I said good, but yeah, you get the idea, right? You should get excited when you see a proof. Right, so what we're going to do, this is the one where we want to prove that this angle is always going to be double the angle on the circumference. You know, angle at center equals 2 times angle at circumference. So what we'll do is we will construct a line PO and we will extend it a little bit. So I'm just going to say here, construct PO and extend. And then you can just make like a O1 and a O2. On most of the exam papers, they give you an answer sheet that you hand in with your exam, so they will see that you've labeled it O1 and O2. Okay? Now, what we need to remember is if you have a triangle, the angle that is on the outside of the triangle, like this one over here, is always going to be equal to the two opposite angles added together. So if this is x, this is y, and this is z, then x will always be the same as y plus z. Okay? So if you look then at this triangle here, sorry, this one here, then you need to identify that O1 is the outside angle. So O1 will be the sum of the other two opposite angles. So that would be angle Q plus angle P1. Now let's just label this as P1 and this is P2. And the reason for that is going to be exterior angle of a triangle. But now we also should realize that OQ and OP are the same length. OQ is the same as OP because they are radii. That would then mean that these two angles are the same. So we're going to say, therefore, angle Q must be the same as angle P1 because they are the angles opposite equal sides. So what we can then do is say, therefore, O1 must be, remember we said that O1 is going to be Q plus P1, but now we could say P1 plus P1 because Q is the same as P1, and so therefore it's going to be 2 P1. So what we then do is we go repeat exactly what we've just done now, but in the bottom triangle. So now we're going to go work in this triangle over here, but we're going to do the exact same thing. So we're going to start off by saying that O2, I don't know why I keep doing that, O2 is going to be the same as angle R plus angle P2, once again, exterior angle of a triangle. But then we're going to say that OP is the same as RO or 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 whatever you want, and that's because they are radii. And then we're going to say, therefore, that angle R must be the same as P2 because they are the angles that are opposite equal sides. And then we're going to say that therefore O2 must be the same as P2 plus P2, which is going to be 2P2. You don't want to use the R and the Q. We want all of it to be in terms of P. So now what we have worked out is that O1 is going to be 2 times P1 and O2 is 2 times P2. So what would this whole angle be? What would this whole angle O be? So angle O, or let's call it ROQ. ROQ, so it's this whole angle, is then going to be equal to 2 times P1 plus 2 times P2. And so if you take out a 2 as a common factor, then it's going to be angle P1 plus P2. Now look at that carefully. P1 plus P2 is this whole angle, right? And what we've just proven is that this angle here is 2 times that. You see again, P1 and P2 is that whole angle, and ROQ is this whole angle. And what we've just proven, therefore, is that this whole angle is double 2 times that angle. So then it says, prove that, so then we can just say, therefore, ROQ is going to be 2 times the angle P. The angle P is that whole thing over there. Okay, so that's how the proof works. We just use the one triangle, and then we do the exact same thing on the other triangle, and then we just conclude. In the diagram, DF is a diameter. Okay, so it's going through the circle center. Chord EG, I'm just looking for stuff that they haven't shown. DF and EG. Okay, they have shown that. And then EGF is 55. Perfect. First question for 2 marks. Give the size of angle D. Right. I immediately saw this. Did you see it? You see the bow tie with these 2 pieces sticking out? So they must be equal because of the angles in the same segment. Once again, I'll show you the bow tie. As you do this a lot, those things will jump out at you. You see it? So it means that these 2 angles are the same, and then it means that those 2 are going to be the same as each other. If you're still not happy with that as the bow tie, then what you do is you look at the angle 55 and you see where does it come from. So you go all the way back to there, okay, and you go all the way back to there. So that means that the chord EF is the one that made the 55, because if you go from the F and you go from the E, it'll create angle G. So where else can you go with that chord? Well, you could go along this way and along that way, and there it comes together at D. So once again, these 2 angles must be the same. So we're just going to say 55 degrees, and that is because of angles in same segment. Okay, this question, O2 is over here, okay? O2 is going to be exactly double that, because we can see that O2 also comes from EF, okay? Remember, EF is the chord that created G. However, O2 is a center angle, whereas this one is on the circumference. So this one, O2, must be double. So O2 is going to be 110 degrees because angle at center equals 2 times angle at circumference. Okay, angle E2, so let's just go fill this in as 110 and then fill this in as 55. Okay, E2, where are you? E2 is over there. Okay, very easy question. If you just look at this triangle here, we know that this is 90 degrees because that's 90 and this is a straight line. So that's 90. And then we can see that this is the angle on the outside of that triangle. And we know that if you have a triangle and you have an exterior angle like this one over here, let's call it x, then that angle must always be equal to the sum of the two opposite angles added together. So this 110 must be the same as this one plus this one. So that's one way to do it. If you're not comfortable with that, then what you do is you use angles on a straight line over here. That'll give you O1. Once you have O1, then you can use sum of angles on a triangle to get E2. Either way is all right. I'm going to use the exterior angle method. Okay, so the first thing we said was that H2 is 90 degrees because of sum of angles on straight line. So we know that that's 90. Then we know that O2 then, which is the 110, is the exterior angle. So it's going to be equal to H2 plus E2. And that's because of exterior angle triangle. And so 110 is going to be equal to 90 plus E2. So if you then solve for E2, you should eventually end up with 20 degrees. Okay. And then E3. So E3 is over here. Okay, let's just quickly fill in what we have. So we know that one, that's 20. And okay, pretty straightforward. Because if you look at this triangle over here, it's an isosceles because these two are radii. So then remember, if you have a triangle like this, and you know that these two are the same, and you know that this is 110, for example, then these corner angles would each be 35. So that all of it adds up to 180, and these two are still equal, right? Okay, but now how do we lay that out for 3 marks? So what we'll say first is that OE is the same as OF because they are both radii, okay? Then we can say, therefore, because of that, angle E3 would have to be the same as F1. Why? Because they are the angles that are opposite equal sides. And so then we could easily work out E3 as, you could say, 180 minus 110, and whatever that answer is, divide that by 2. And that's going to give you 35. And that is because of the sum of angles in a triangle. So you know why I divided by 2? Because these two angles are exactly the same. So I said 180 minus 110, which is 70. And then that means this would have to be half of 70, and this would have to be half of 70. Okay. And so we've worked that out. So these are both 35 and 35. Okay. Now, this question says, determine the length of OH, which is here, okay, if the diameter is 10 and GE is 9,4. So GE is 9,4, okay, so that's 9,4, and then the diameter is 10, okay, and they want us to find OH. This one. Okay, so I was looking at this and thinking maybe we could do like some Pythagoras, but then I just realized we've got a 90-degree triangle down here, right? If I just redraw that triangle, let's just do this. So we've got a 90-degree triangle with, okay, we don't technically know what this length is, but it's going to be exactly half of that. I will explain why now. And then we have this angle 55. And we're going to get this as 4.7. Let's quickly go do that first. Let me start with that. So we can start off by saying that HG is going to be 4.7. Let me explain. Because remember, if you have a line from the center of a circle hitting a chord at 90 degrees, then remember, it divides that chord into 2 equal halves. That is the whole line from center perpendicular to chord. Remember, if you have, let me just show you once more. If you have a circle and you have a chord and you have a line coming from the center and it hits that chord at 90 degrees, then it divides those two chords into equal halves. So here we have it here. We've got the center, we've got a line hitting a chord at 90 degrees. So that chord, which is this one here that I'm showing in red now, would have to be cut in half. So that means this piece would be 4.7 and this piece would be 4.7. So we now have that. Now, because it's a 90-degree triangle, we can actually use grade 10 trigonometry to find anything else that we need. So what I'm thinking we should do is let's go find this length over here. Okay, this piece here, this HF part, which is over here. So if we use this 55 degrees, then that length that we're looking for is the opposite, and we already have the adjacent. So that would be tan. So we would say tan 55 equals to the opposite over the adjacent. And then to get HF alone, you would just multiply the 4.7 over. So you would end up getting that. And so HF is 6.71. So HF is going to be 6.71 units. Okay, so now if you look carefully, they told us that the length 10 is this diameter. But now that means that from O to F would be 5, and from O to D would be 5. So if we know that, because remember the radius is half the diameter, so if we know that this whole length here, we've just worked that out as 6.71, and then we know that this piece here is 5, then how would you get OH? Well, you could just say that OH is going to be 6.71 minus 5, and that would be 1.71 units. In the diagram below, AT is a tangent. Okay, so AT is a tangent. Chords BT, BV, and VC are drawn. CV is extended such that those are parallel. BC is equal to CV. Okay, they've shown us that already. And that's equal to x. So when I read this, I'm just looking for something that isn't shown, okay? Now, determine with reasons 3 angles that are equal to x. Okay, so the first one is parallel lines. So have a look here, there, there, there. So that would be B1. So B1 will be equal to x, and that is because of alternating angles, and that is because the line BC is parallel to the line TV. Okay, so we've got that one. Now the next thing I would always go jump at is the tangent. They always like to throw in tan chord. So there's the tangent, there's the chord. Here's the angle in between the tangent and the chord. So that angle will be the same as any other angle that this chord makes. So where does this chord come together? Well, if you put your finger at B and you put your finger at T, if you go towards V, your fingers will come together again, and that's what you want. There we go. So that means that T2 and X, or T2 will also be equal to X, because of the tan chord theorem. Okay, so we've now got that. Now we just need one more. Oh, we already said that this was x, right? Now we know that these two sides are the same. So if you have two sides that are the same in a triangle, then the opposite angles are also the same. So that's going to be V1. And that's because we now have the angles that are opposite equal sides. Okay, and now this question. If ATVC, so ATVC, okay, so that whole shape. If that's a parallelogram, prove that AT and BT are the same. So AT and BT. Okay, so they want us to prove that this and this are going to be the same. Okay, now listen to me carefully. When they often do that, to prove that these two sides are the same, very often what we're going to have to do is eventually show that these two angles are the same. If we can show that those two angles are the same, then it automatically means that these two sides are the same. So that's typically what will probably end up happening. Okay, so just keep that in mind. Okay, so one of the properties of a parallelogram is that the angles opposite each other, so this one and this one, they must be equal. So you can see this is 2x, x and x, so that's 2x. So angle A is going to be the same as angle CVT, which is this whole angle over here. And that is because of opposite angles, so opposite angles of a parallelogram, which we just call it a palm. So that means this is 2x. Now the next thing we can do is realize that we have a cyclic quad. And we know that one of the properties of a cyclic quad is that if you have the exterior angle over here, for example, A, then that would have to always be exactly the same as the interior opposite angle, B, for example. So if you look at B3, that's the exterior angle of the cyclic quad. So what would it be the same as? What would be the same as the interior opposite angle? So it would be the same as the whole of angle V. So we could say B3 is equal to angle V, which is equal to 2x, because you see it's x and x, and that's because of exterior angle cyclic quad. And so look at that. Remember earlier we said that very often when they want you to prove that two sides are the same, it's often going to be the angles, because now that these two angles are the same, we can say that the sides are the same. So we can now say that therefore AT must be the same as BT, and now it is because they are the sides that are opposite equal angles. Don't say angles opposite equal sides. Now we have the sides that are opposite the angles that are equal. See, the angles are equal. Okay, and then we've proven that question. And now lastly, determine the value of x. Very easy. You could just work on this triangle here. We know that angle A plus angle B3 plus angle T2 should all add up to 180, and that is because of sum of angles in a triangle. And so we can just say 2x plus x must equal 180, so 5x must equal 180. You divide both sides by 5 and you will end up with 36 degrees. DE is a tangent to the larger circle, okay, and DH is a tangent to the smaller circle. And then, okay, chord, F are points of intersections. Okay, the first question says complete the following. D3, so angle D3 is equal to which angle plus which angle because of exterior angle of a triangle. Right, let's talk about that. If you have a triangle and let's say you've got some angle A1, 2, B, and C. We know that A1 is called an exterior angle, and we should know that A1 is always equal to the sum of the other two angles added together, so the opposite two angles added together. So if D3 is an exterior angle, then it would have to be the exterior angle of this triangle there. It's the exterior of that triangle. So D3 would then have to be equal to H1 plus E1. So H1 plus E1. And then we must just put these little angle symbols. Prove that DEFH is a cyclic quad. So DEFH is a cyclic quad. Okay. 3 ways to prove something is a cyclic quad. First method, if you have something like this, and if the two angles opposite each other, if they add up to 180, then it's a cyclic quad. Number 2, if you have something like that, and you've got a exterior angle. If that exterior angle is the same as the opposite interior angle, then it's a cyclic quad. And then lastly, if you have a cyclic quad, or if you have a four-sided shape, sorry, and then you've got something like this, if you can then prove the bow tie, so you can either prove that those two angles are the same, or if you can prove that those two angles are the same, for example, then it's also a cyclic quad. Can I tell you a scary story quickly? Looks quite hectic. Okay, let's carry on. We'll tackle that horror story when we get there. Prove that. Okay, so D, E, F, H. Okay, so we got to try to figure out, what this is going to be. Okay. Okay, and I was quite suspicious of the fact that they've already done this, so I think it's going to build on that. Check this out. If we look at, okay, let's break this down. If we look at this tangent over here, then we know that if you have a tangent and you have a chord, okay, and remember we're only looking at this circle here right now, just the circle here. If you have a tangent and a chord, and you have the angle in between the tangent and the chord, then that angle must be the same as any other angle that is made by that chord in that circle. So for example, that chord comes together at G2, so they would be equal, but it also comes together at F2, okay, and that's the important one. You'll see why now. So we can say that H1 is the same as F2, and that's just because of tan chord theorem. Okay, so, and look, they used H1. You'll see how this is all going to tie in together now. Then I want us to quickly jump to the other tangent, which is over here, and then let's make a chord. So now we're in the big circle. Now we are in this circle here. And if you take the angle that is between the tangent and the chord, then that angle must be the same as any other angle that that chord makes in that circle, which is only going to be here at F1. So E1, which I'm also curious about because of that, is going to be the same as F1. So E1 is going to be the same as F1, and that's because of also the tan chord theorem. Now, look how this all comes together. We are eventually trying to prove that this is a cyclic quad. And we know that one of the properties of a cyclic quad is if this angle on the outside is the same as the inside angle. So look at this D3. We know that D3 is equal to H1 plus E1. We've proven that in the previous question. But now we've just proven that H1 is the same as F2 and E1 is the same as F1. So then D3 is now equal to F2 plus F1, which is this whole angle. So look at that. You now have the exterior angle of a cyclic quad, the exterior angle over here being equal to this one over here. So it must be a cyclic quad. Quite crazy, hey? You might have to watch that a few times because obviously as I'm explaining it, you're just following along, but pause and actually think about what I'm saying and you'll see it all makes sense. And so then we can conclude by saying, therefore, DEFH is cyclic quadrilateral, and that's going to be converse exterior angle cyclic quad. Okay, this 11.3, prove that DF, where are you, DF? DF is here, okay, bisects angle HFE. E. H, F, E. Okay, so we have to prove that these two angles are the same as each other. Okay, so yeah, remember what we got to try to prove is that those two are the same. Now what we must remember is very often they like to base the next questions off previous things. So we've just had to show that this is actually a cyclic quad. And so because it's now a cyclic quad, all of the cyclic quad properties are, we can use them. One of them is that if this is now a cyclic quad, we can use angles in, whoa, that's actually a good circle. We're now allowed to use angles in the same segment. So if you look at this chord over here, that chord makes the angle F1. It makes, oh, come on, Kev. It makes the angle F1 like that. But it also makes the angle H1. You see? So we're going to start there by saying that H1 is going to be the same as F1 because they are the angles in the same segment. Even though it's not a circle, as long as it's a cyclic quad, you can use this. Okay, so we've now shown that this angle and this angle are the same. However, if you remember earlier when we were looking at this tangent to this circle and we looked at this chord, we said that H1 must be the same as F2, right? H1 is the same as F2, and that's because of the tan chord theorem, which we already showed earlier, tan chord theorem. So now can you see it? If H1 is equal to F1, but H1 is also the same as F2, then from that, we must be able to say that F1 is the same as F2. And that is exactly what we were trying to show. Prove that DF bisects HFE. And so we can then say, therefore, DF bisects HFE. Okay, and the last question. Okay, this one says, if K1 is equal to E1, so K1, okay, is equal to E1, E1 is over there, okay, prove that GK, okay, this one here, is a tangent to the larger circle at K. All right. So pretty much, they always like to ask this. What the question is actually asking is the following. If, okay, so we've got the circle, okay? Now, if this is a tangent, then here's a chord. Then the angle between them should be equal to the angle that this chord makes in that big circle, which would be E2. So if we can show that K2 is the same as E2, done. Okay? That's what they're actually wanting to show, because if we can show that those two angles are the same, then it means that this must be a tangent. Okay, so that's what we're going to actually try and do in this question. Knowing that K1 is the same as E1. Oh, there's so many angles that are actually the same in this question. These two are the same. And then we know that H1, because of the tan chord theorem, was the same as that one. And then earlier we showed that this angle from its tangent is the same as this one. Okay, so that's kind of what we have at the moment. Oh, but then I guess this must also... Okay, so actually all of these angles are equal to each other. So I'm just going to show one line. They all equal. And then we also showed earlier that this tangent was also... That angle was also equal to this one. I don't know if you remember that. Okay, so I've spent the last 10 minutes just staring at this diagram. And I think I finally found something. It's not easy though, but this is what I found. if we look at this original cyclic quad that we proved earlier, this angle here is the exterior angle of that whole cyclic quad. So it would have to be equal to this whole part here. Okay, but we'll get to that just now. What I first want you to look at is this tangent here, okay, and this chord. So if you just use the tan chord theorem, you would notice that this angle H4 would have to be the same as K1, okay? So I'm going to say that H4 is equal to K1 tan chord theorem. So now we can put a little line there to show that that angle is the same as K1, which is the same as all of these other angles. Each of those are the same. Okay? Now, if we then say that this whole angle on the outside is the exterior angle of that yellow cyclic quad, then it means that this whole angle on the outside must be the same as this whole angle. Okay? So let's say that. Okay, they haven't really given us a letter. So let's go H3 plus H4 must be the same as the whole of angle E. So DEF. And that is because of exterior angle cyclic quad. Okay? But instead of DEF, I'm going to say E1 plus E2. Okay? But now we also know that H4 is the same as E1. We can see that. Okay? So we can just say H4 is the same as E1, and we've already proven that. So therefore, if H4 and E1 are the same, then it means that H3 must be the same as E2. So H3 must be the same as E2. Okay, so we've already got E2 slowly but surely coming into the picture. So we know that H3, which I'll do with 2 lines, well, yeah, I'll just do 2 lines because we're not saying that H3 is the same as all of these others, and that's the same as E2. But if you then look at this over here, and you just use angles on the same segment, what is H3 the same as? Well, H3 is the same as K2, and that's because of angles in same segment. So what we've said is that H3 is the same as E2, but H3 is also the same as K2. So therefore, E2 must be the same as K2, and so therefore, that is exactly what we wanted to prove. We can then therefore say that GK is a tangent, and that's going to be converse tan chord